Point defect in solids. देखिए, as we know that the solids are made up of cations and anions. Cations are those radicals which are having positive charge, and anions are those radicals which are having negative charge. The second thing is the ionic solids are neutral. Neutral means the total positive charge in ionic solid always equal to the total negative charge. If the positive charge is not equal to the negative charge, in such case the ionic solids are unstable. Now we will talk about the ideal crystal, or I can say the perfect crystal. Ideal crystal or perfect crystal, when there is no defect in a crystal, it is called as ideal crystal. If there is any defect, then it is called as non-ideal crystal. Supposed to be we are having a solid in which A positive, B negative, A positive and B negative. At alternate position there is A negative and B positive. Here is A negative, A positive, then B negative. After that A positive, B negative, A positive. Then there is A positive, B negative, A positive and B negative. An ionic crystal in which the constituting particles are repeated continuously and there is no dissimilarity at any point is called as ionic crystal. In this crystal, after A positive there is B negative, and after every B negative there is A positive. So this crystal I can say is a perfect crystal, or I can say this is an ideal crystal. In case of the defective crystal, this anions may replaced from the crystal lattice. This is called as crystal lattice. This is called as crystal lattice. So in defective crystal, supposed to be any one of the ion is missing, supposed to be at this point B negative is missing. So I will say a defect is created at point B negative. Some another type of anion may occupy this interstitial site. These are called as voids, or I can say interstitial site. So interstitial site. Some other ion may occupy, supposed to be Z positive or supposed to be X negative. So in this case also this crystal will become defective. In the ionic crystal, the cation always metal. A positive is cation here and cation is metal always. In the same way, the B negative in this crystal is anion and anion is a non-metal always. So point defect are basically of two type, which are included in our syllabi, but in actual they are three types. The first one is called as non-stoichiometric point defect. The first one is, second one is the stoichiometric point defect, and third one is the impurity defect. Non-stoichiometric point defect means if the ratio of cation and anion is different before and after the defect, or I can say if the ratio of metal and non-metal is different before and after the defect, then it is called as non-stoichiometric point defect. Similarly, if the ratio of cation and anion is same before and after the defect, then it is called as stoichiometric point defect. Impurity defect means if some external impurity is added in a pure crystal lattice, then it will create defect that is called as impurity defect. So the example of second stoichiometric defect is A is the Schottky defect and B is the Frankel defect. Frankel defect. In both this defect, the ratio of cation and anion after and before the defect is same. In non-stoichiometric point defect, as we know that the ratio of metal and non-metal, or the ratio of cation and anion is different. So there are two possibilities. First one, this metal can be in excess than non-metal, so I can say the metal excess defect. And the second one, this non-metal may be in excess as compared to this metal, so I can say metal deficient defect. This metal may be deficient or this metal may be in excess. So non-stoichiometric point defects are further divided into two types. The first one is the metal excess defect, and second one is the metal deficient defect. Metal deficient defect. The metal may be accessed in two ways. If there is anion vacancy, anion is removed, or I can say the non-metal is removed. Anion vacancy, or when extra cation occupy the void, interstitial void. In the similar manner, the metal deficient defect may be of two way. First one, when due to the cation vacancy, cation means metal, cation vacancy, and second one is the when an extra anion occupy interstitial site. So let's start the Schottky and the Frankel defect, that is stoichiometric point defect. As we know that the in stoichiometric defect, the ratio of metal and the ratio of non-metal, or I can say the ratio of cation and anion before and after the defect is same. So these are called as stoichiometric point defect. The first one was the Schottky defect, and the second example was the Frankel defect. So let's start with the Schottky defect. A defect takes place in such a way that the equal number of cation and anions are removed from the crystal lattice. In this effect, this B negative is removed from the crystal lattice, and similarly from here the A positive is removed from the crystal lattice. So I can say equal number of cation and anions are removed from crystal lattice. Such type of defect is called as Schottky defect. After before the defect, the metal, or I can say the cation A positive, कितने हैं यहाँ पर 1 2 3 4 5 and 6, and anions, or I can say the non-metal means B negative is also 6. The total positive charge before the defect is +6, and the total negative charge before the defect is -6. So before the defect, this crystal is ionically neutral crystal. After defect हम चेक करते हैं. after defect the number of metal ion A positive is equal to 5, and non-metal, that is B negative, after defect is 5. So total positive charge before after defect is 5, and total negative charge after defect is 5. So after defect the crystal is ionically neutral. So in every case, before and after the defect, the crystal must be ionically neutral. Secondly, the ratio of A positive and B negative ion before the defect is 6:6, and the simplest ratio is 1:1. After the defect, the ratio of cation and anion is 5:5, and simplest ratio is 1:1. So the stoichiometry means simplest ratio do not change before and after the defect in case of the Schottky defect. Example in which the Schottky effect takes place, some of them are sodium chloride, potassium chloride, potassium bromide KBr, and cesium chloride. Schottky defect ज़्यादातर तब more commonly होता है when the coordination number is very high, like as if the coordination number is 6 or 8. Like as cesium chloride, the coordination number is 8, and in this case the coordination number is 6. In Schottky defect, as we know that the cation and anions are removed from the crystal lattice, so the defected crystal will become less denser as compared to before the defect. So I can say after the Schottky defect, the density is decreased. The density of the crystal decreases after Schottky defect because ions are removed from the crystal lattice.